Right, guys, Radian Measure. Radian Measure, it looks at the ratio or the fraction that the arc length is compared to the radius. So if I have some angle and it's forming a sector within my circle, that angle that forms that sector has an impact on how long that arc length is. And because it has a direct impact on how long that arc length is, those two are related in sense that the angle is causing the change in the arc length. And what we do with radians is we go, okay, well, if I've made a sector so big because of an angle, what is the impact that the arc length, or what is the fraction that arc length has over the radius? And when we look at that fraction or that ratio, that's what we describe as a radian. And since radians are described as a fraction, we don't need to give them units. And that has benefits to us down the track when we want to introduce calculus and trigonometry together. And just for fun, radians are an international standard for measuring units, particularly units of angles. So how does that relate to our unit circle? Well, the beautiful thing about the unit circle is that it's one of the mathematician's favorite numbers. It's the number 1. And because it's the number 1, that then the angle that we make is just the arc length divided by 1. So if we're going to go through, let's look at an example here with 360 degrees. Well, arc length, if we just remember, is just a fraction of the circumference. Right? And the circumference of a circle is just 2 pi r. And in the case of the unit circle, because r is 1, we're just going to be dealing with 2 pi. All right, so if that's the case, then when it comes to 360 degrees, well, we've got just 2 pi times, the radius of that circle, which is 1, so it's just 2 pi. And we've got to divide it by the radius of that circle, so 2 pi over 1, and that is just then 2 pi. So I can describe 360 degrees as a fraction of the radius not the radius, the arc length, or in the case of a 360 degrees, the full circumference of the circle divided by its radius. So 360 degrees, an equivalent fraction to describe 360 degrees is 2 pi. Much the same way that we think about 180 degrees. What do I know about 180 degrees? Well, remember how we said that the arc length is just a fraction of the unit circle. So I can think of 180 degrees as 180 over 360 times 2 pi. And when I'm looking at this, as a mathematician, don't like big numbers, let's simplify where we can. Well, I know that this simplifies to a half, and a half times 2 pi, well, a half times 2 pi is going to result in those two also simplifying out. And what we are left with is 180 degrees is equivalent to pi, which makes sense. 180 degrees is half of 360. If we said 360 is 2 pi, halfway around must be pi. And in terms of that fraction of that rate as a radian measure, remember, because it's part of the unit circle, it's just pi over 1. And again, we don't, mathematicians, pi over 1, we don't need to say it. Pi divided by 1 is just pi. So here we've got 2 real key base elements. Now I can describe 360 degrees as 2 pi, and I can describe 180 degrees as just pi, which is half of 360. So moving on. 2 pi radians is equal to 360 degrees. 1 pi radian, or just pi radians, is equal to 180 degrees. And we've got a couple ideas to convert. To convert from degrees to radians, we multiply by pi over 180 degrees. Make a bit more sense why it's exactly pi over 180 degrees. When we think about that, 180 degrees is just pi. So thinking about that, if 180 degrees is equal to pi, if I divide both sides by 180, 1 degree is equal to pi on 180. Right, so there's where that comes from. Right, and then to convert from radians to degrees, because that's just the opposite from converting to degrees to radians, we're just going to flip it and do the reciprocal of it. So if to change from degrees to radians, I multiply by pi on 180. Well, to reverse that change, I'm just going to multiply by 180 over pi. Hopefully that's okay. Moving on quickly. So looking this, convert 90 degrees to radians. Well, to convert 90 degrees to radians, what I'm looking at doing is multiplying it by, what do we have to do it again? Pi and 180. So what I'm going to end up doing is 90 times pi over 180. Well, 90 is technically 90 over 1. When I think about that, that becomes 1, that becomes 2. Simplifying, so 90 degrees is just pi on 2. Hopefully that's all right. And at the same time then, if 90 degrees is pi on 2, 45 degrees must be half of pi on 2. So 45 degrees is pi on 4, right? That's important because that's one of our exact values, right? 90 degrees, also handy to remember as well. It's pi on 2, which makes sense because if 90 is half of 180 and 180 is pi, pi needs to be divided by 2 as well. All right. Looking here at example 2, convert minus 300 degrees to radians. Well, nothing's going to change here. I'm going to do minus 300 times pi over 180. And when I look at that, 300 and 180, 30 and 18, they've got a highest common factor of 60. 60 fits into 300 5 times, 60 fits into 180 3 times. So negative 300 degrees is negative 5 pi over 3. Right. Notice how it's an improper fraction, and an improper fraction that's greater than 1, but we can see it's less than 2, because if it was 6 pi over 3, that would equal 2 pi, or negative 2 pi, sorry. So recognizing that that's an improper fraction, gives us an idea that theta is greater than 180 degrees. But because that fraction is going to be, because the fraction in itself is, what do I want to say, the fraction is less than 2 pi, it's less than 360 degrees. I can write that better. You're a math teacher. Theta is going to be less than 360 degrees. All right, so just some simple things there about recognizing fractions and what we remember about fractions, and that they're greater than, less than. Okay, convert question 3. So if I'm looking at this, 2 pi over 3 radians 2 degrees. So looking at my fraction, my fraction's proper. It's a proper fraction. So theta is going to be less than 180 degrees. I can check that out from looking at it. Now let's actually do the conversion. Remember, to convert from radians to degrees, we do the opposite from degrees to radians. So if from degrees to radians, we multiplied by pi over 180, we're going to multiply 2 pi over 3 times, what do we want to do that over? We want to do this pi over, nope, silly boy, 180 over pi. And let's simplify fractions. Pi's cancel each other out. 180 and 3, that's going to become 1. That's going to become 60. So we are just left with 2 times 60 in the numerator, and our denominators are just going to become 1. So what we have here is 2 times 60 is 120 degrees, which is like I thought, because my fraction was a proper fraction. And notice that that one is equal to an exact ratio, right? And that exact ratio that we know it's related to 60 degrees. We know it's related to 60 degrees because it exists in that second quadrant there. Right, hopefully this isn't too much. Hopefully you guys are okay with this. So going to example 4, convert 4.2 radians to degrees, correct to 1 decimal place. Right, so 4.2, again, the same way, we're going to do 4.2 times 180 over pi. And at this point here, what we're going to do, I'm going to drag out my calculator. And with my calculator, I'm literally just going to do 4.2 times 180 on pi. So 4.2 times fraction pi, oh, no, 180. 180 over pi. And here we can see it's 240.6422. So that just becomes 240 point, how many decimal places? 1, so 6 degrees. Cool. Now we're back. I want to evaluate cos of 1.145 correct to 2 decimal places. Usually in the question somewhere previously, they'll give you the fact that what you're looking at is in radians. So I'm going to tell you that this is in radian measure now. So that has implications when it comes to our calculator. So going back to the calculator, so sharing my calculator with you guys again, I'm going to clear this. And right now you can see up the top of my calculator, there's a little D standing for degrees. When I'm operating with radians, I need to change that. So to change that, we're going to go shift, and I'm going to go setup. And when we go to setup, you can see option 3 is degrees, option 4 is in radians. We're coming into this world where we're going to be expecting you to be comfortable with using both. So be super cautious each time you do an exam of what setting your calculator's in, because radians and degrees are vastly different answers on the calculator. And what we had to evaluate cos of 1.145, and we hit equals, and we can see that it's 0.4130. And that makes sense to us because remember that with cosine, going back to the unit circle, cosine has a maximum value of 1 and a minimum value of -1 as it rotates around that circle. This falls straight within that. So that is something that we would have expected to see. So cos of 1.145, we said was equal to 0.413, which equals just 0.41. getting towards the end of these examples here. So just remembering that our calculator is now in radian measure. So if we're going to come back and do anything with degrees, we've got to remember to convert between those two. Question 6 here says find the exact value of tan of pi of 3. So something I just want to point out, it mentions this word exact. Whenever you see trig, tan, and exact values, that's a clue that somewhere we are going to be using these from our reference sheet, right? We don't know at the moment which one it's going to be, but it's one of those two triangles straight away. Our set squares, our 30-60 sets, or 60-30 set squares, sorry, and our 45. So before we can go anywhere, we need to know what is pi on 3. Well, pi on 3, if we think about it, let's convert that. So pi over 3 to convert from radians to degrees, it's just pi on 3 times 180 over pi. Simplifying fractions, pi's cancel each other out. 180 divided by 3 is 60 degrees. So we have here that we know that pi on 3 is equal to 60 degrees. Because pi on 3 is equal to 60 degrees, going to our unit circle, 60 degrees is opposite over adjacent. So tan of pi over 3 is equal to root 3 over 1, opposite over adjacent. So it's just equal to root 3. Okay. In question 7 there, looking at the exact same way as in question 6, we've got to convert pi on 4. Hopefully from earlier, you remember that pi on 4 was equal to 45 degrees. If not, pi on 4 times 180 over pi, well, you know, they're going to go out. On your calculator, you can put 180 over 4, which is just going to simplify to 45 anyway. So cos of pi over 4 is equal to 45 degrees. Cosine's adjacent, so it's 1 over root 2, which equals root 2 over 2, because we don't like irrational numbers in our denominators. All right. Hopefully you guys are okay with that. We know that this here is going to be 0 slash 2 pi. I know this is pi on 2, and this one over here is pi. Now, remembering that our third quadrant was 180 plus theta, but because we're dealing with radians, it now just becomes pi plus theta. So 270 degrees is pi plus pi on 2. So 270 degrees equals pi plus pi over 2. Well, what we're going to hope, and what you guys are going to be able to do if you're not very comfortable with, is remember how to add fractions quickly. Pi, I need a common denominator of 2, so it's just going to become 2 pi on 2 plus pi on 2. Hopefully that wasn't too bad, which is just then 3 pi on 2. Our fourth quadrant is just going to be 2 pi minus theta. First quadrant is going to stay theta, and this one is just going to be pi minus theta. So, you know, keeping those things in check. So remember, we know that we've got 30 degrees, 45 degrees, 60 degrees. There are some of our main exact ratios. With 30 degrees, that is pi over 6, 45 was pi on 4, and 60 is pi on 3. So if we've got that, moving on, then dragging this along here, if we have that, well then 150 degrees is just going to be pi minus pi on 6, which, you know, pi minus pi on 6 needs to become 6 pi on 6 minus pi on 6 becomes 5 pi on 6. 45 degrees, well, 180 minus 45 is 135, so 135 degrees is going to be equal to, again, pi minus pi on 4. So this becomes 4 pi on 4 minus pi on 4, which equals 3 pi over 4. And the exact same thing, 120 degrees equals pi minus pi on 3, which becomes 3 pi on 3, which becomes 2 pi over 3, right? Hopefully that wasn't too fast for you, but one thing I wanted to point out from there is that it's important to be able to add fractions and add fractions quickly, all right? Hopefully that's okay. Complete the work that's on OneNote in terms of radians and exact values, and I will catch you guys later.